Hi guys, today's lesson is 6.1. We're just going to kind of go through this fairly quickly. I think this will be fairly simple for most of you. Ordered pairs can be used to show inputs and outputs. So inputs are basically our x values and our y is usually our outputs. So if we have ordered pairs, we kind of think of them as that. The key idea is relations and a mapping diagram. Some of you may or may not have seen a mapping diagram before. A relation pairs the inputs, the x values, with the y outputs. A relation can be represented by ordered pairs or a mapping diagram. So we can show it with ordered pairs. We can also show it with a mapping diagram. So a mapping diagram puts the inputs, which in general, again, is your x's, and these are generally your y's in your ordered pairs. And you put your 0, 1, 2, and we usually write these in order from least to greatest. And then you write your ordered pairs, or not your ordered pairs, your outputs in order from least to greatest. And then you draw a line of what they go to. So 0 goes to 1, 1 goes to 2, 2 goes to 4. Notice that these are arrows and they're pointing towards the output. There's not an arrow on this side because it doesn't go back and forth. It just goes from input to output. So that's really important that the arrows are going that direction. Listing ordered pairs of a relation. List the ordered pairs shown in the mapping diagram. So here's your inputs, your x's, here's your outputs, your y's. So the ordered pairs are 1, 3, 2, 6, 3, 9, and 4, 12. Notice they're in parentheses and they're separated by commas. For this one, it's a little different because you don't have the arrows going directly across. So you have 0, 0, 2, 1, 2, negative 2, and 4, negative 3. So those are the ordered pairs that you get. You have to follow the arrows. So on your own, if you were listing, go ahead and you can turn the page. And when you turn the page, on the back is a place for you to write these. You're going to write the ordered pairs, or you can just write them below here. It doesn't matter. And then do the same thing here. So go ahead and pause and take it. Okay, these are the ordered pairs that you should have had from the on your own 1 and 2. Okay, the next part, a relation that pairs each input with exactly one output is what we call a function. So each input can have only one output. So determine whether the relation is a function. So negative 9 has one output, negative 2 has one output, 5 has one output, and 12 has one output. They both share the 10, but each input has only one output. So since there's only exactly one output, this would be considered a function. On this one, negative 2 has an output, negative 1 has an output, but 0 has two outputs. Because 0 has two outputs, this is not a function. All right, let's go back to these. This would be a function because each input has one output. 0 has one, but 2 has two outputs, so this would not be a function. This one would be a function. Each input has exactly one output. This would not be a function. Describing a mapping diagram. Consider the mapping diagram at the left. Determine whether the relation is a function. Each input has exactly one output, so this would be a function. Describe the pattern of inputs and outputs in the mapping diagram. Look at the relationship between the inputs and the outputs. So if you look at the inputs, as each input increases by 1, the outputs are increasing by 15. So as each input increases by 1, the output increases by 15. So on your own, determine whether the relation is a function, and then describe the pattern of inputs and outputs in the mapping diagram on your own number 4. So go ahead and on the next page do that. Okay, number 3 is not a function, and number 4 is a function. So if we go back to that, and you can see that number 3, it has 2 outputs for the 1 input. And this one, each one has 1. And number 5 is as each input increases by 2, the output decreases by 3. I also want to go over 6.2, just the beginning of this, not a lot. So functions as an equation. So we talked about them being an ordered pair and a mapping diagram. We can also put them as an equation. A function rule is an equation that describes the relationship between the input values, which we call the independent variables, and the outputs, which are called the dependent. The dependent depends on what we put into the function rule machine, in a sense, or the function rule. So this is dependent on whatever we decide to put in, okay? Write a function rule for the output, or for the output is 5 less than the input. So when we think of output, we generally think of that as our y, and our input is typically our x. So we would take the output is y, is an equal sign, 5 less than the input. Input is x. Okay, the word than means we have to flip it because we have 5 less than the input, so it would be x minus 5. So the function rule is y equals x minus 5. For this one, write a function rule for the output is the square of the input. So the output is y, is an equal sign. The square of the input, which is x, gives me x squared. So y equals x squared. So the function rule is y equals x squared. Okay, what is the value of y equals 2x plus 5 when x is 3? So this is what we kind of did with the equations before. We're going to take out the x, put in the 3, and then solve. So when x equals 3, y equals 11. Okay, so what I'd like you to do now is I would like you to do on your own 1, 2, 3, and 4, and you can do that